Hocam sesiniz gelmiyor ama. Hocam sesiniz gelmiyor.
Şimdi geliyor mu arkadaşlar?
Geliyor hocam.
Tamam, kusura bakmayın. Ben tabii arkam dönük olduğu için mesajlarınızı da görmedim. Tamam. Şöyle kabaca hatırlatayım. Geçen ders bu teoremi ispat etmeye başlamıştık. İşte phi map'imiz var. Integer'lardan fundamental gruba. It maps any integer to the homotopy class of W and S, which is the loop based at x0 that goes around the circle counterclockwise n times. And the setup was, we have this covering projection P, and we have a lift of W. What we mean by a lift actually, is described in this picture. You have this loop, and W and tilde is a lift of it. So it maps to the covering space, so that when you project down via P, you just get back to Wn. That's why we will call it a lift of Wn. And the first part of the proof was that this is a homomorphism. And to show this, we had this observation that the homotopy class of this loop is equal to the homotopy class of a composition like this for any continuous path f tilde from 0, 1 into R, so that f of 0 is f0 tilde is 0, like this function, and f0 tilde 1 is just n, like again this one. Okay, so this observation is crucial, and the reason was that this is true since wn tilde and f tilde are homotopic. Paths, homotopic paths that keeping via a homotopy, keeping the endpoints fixed. Namely, we have a homotopy like this, okay? Ona evet f demiştim. So this end of the homotopy is mapped to 0 on the real line. This end is mapped to n, and here I have wn tilde, and here I have f tilde. Okay, f tilde, and f was, of course, I can just write down f as follows. This is just 1 minus t times wn of s plus t times f tilde of s. Okay, this is the homotopy. Okay, now to show this is an homomorphism, we may proceed as follows. Okay, so I just write this. So we have to prove this. This is equal to this product. Here, this is the product of homotopy classes. Now, to show this equality, I start from the right-hand side and show that it's equal to the left-hand side. And we proceed as follows. This is the homotopy class of Wm. And this is the homotopy class of Wn. Well, the product of the homotopy classes is just the homotopy class of the product of the paths. So it's equal to this one. Here, Wm dot Wn of S, the product of the paths is this. It is just Wm 2S. S is between 0 and 1 over 2. And Wn of 2S minus 1. If S is between 1 over 2 and 1. Okay, now Wm is just P composition Wm tilde. No, I should write it this way. Here I have 2S. And this is just P composition Wn tilde 2S minus 1. Here S is between 0 and 1 over 2. And here it is 1 over 2 and 1. Then what? I can just write down what Wm is. Wm is just right, Wn tilde S is just n times S. So if I just plug it here, so we get P of 2ms as S between 0 and 1 over 2, and this is just P of 2s minus 1 times n. Evet. S is between 1/2 and 1. And that is equal to what? I can proceed as follows. This is P of 2ms if S is between 0 and 1/2. And here I write the following. Instead of this, I will write 2s minus 1 plus, times n plus m. So inside P, I will just add m here, okay? I can do this because P is periodic with period 1. Therefore, if you add an integer to this expression, the value of P doesn't change, okay? But the thing is the following. Now, P is, this map is the composition. I can write it like this. So this is equal to this gadget, where alpha S is the following continuous path. So it is just 2ms if S is between 0 and 1/2, and it is 2s minus 1 times n plus m if S is between 1/2 and 1, which is a continuous path, is a continuous path from 0 to m plus n. Değil mi? Bakın şimdi 0 koyduğunuzda 0, 1/2 koyduğunuzda m'de, buna 1/2 koyduğunuzda m'de, 1 koyduğunuzda da n artı m'de. Okay. Now this is a continuous path, and then I'll come here and use this observation, which was saying that the homotopy class of anything like this is the same as this one, where f tilde is just any path joining 0 to n. In our case, pardon, şöyle. So we will use this observation, okay? This is equal to this guy, provided that f is a path from 0 to n, right? 0 to n. Now, alpha is a path from 0 to mn. Therefore, this wm dot wns, which is equal to P of alpha s, is the same as, no, it is not the same as this one. The homotopy class of this, is the same as the homotopy class of w m plus n tilde s. Okay? Yes. Hence, this gadget, which is just Wm times Wn s, and this is equal to this gadget, but this thing is just Wm plus n homotopy class of this. Aslında burada s yazmaya gerek yok. Homotopy class of this, but this is just by definition n plus n. Okay, so this map is a homomorphism. Okay. Hence, this thing is a group homomorphism. Next, yes. What? Here? But no, I just want to write the following. You know, this is P composition of a path, and this path is given like this. And now this is a continuous path joining 0 to n plus n. Okay? Here, if you don't write this, you cannot do this because this is a path from 0 to m. This is another path from, so when you plug 1 over 2, you get 0, 0 to n. So there are two paths starting from 0 to m and n. They do not form a continuous path. But if you do this, then I can write it this way, and this becomes a path from 0 to n plus n. It's a continuous path. Then I can replace it by this, by the observation we did in the beginning, and then we are done. Now, to show that this is an isomorphism, we have to prove two things. Next, we need to show that this map is injective and surjective. Okay, now to do so, we need the following facts that we will prove soon. But let me first write down these facts. You know, what are they? The first fact is the following. Bu arada şu ekran görüntüsü fena değil herhalde. Yok, bu kötü. Şu nasıl? Kötü. Evet, bu daha iyi. Okay, now the first fact is the following. For each path, I mean continuous function, okay, starting at a point x0. This x0 is not necessarily the x0 here, okay? This is any point x0, and each x0 tilde in R so that P of x0 tilde is x0. There is a unique lift. So lift is just a function. Okay. This time it goes to R. Starting at x0. So lift means so this lift means the following. F is just P composition F tilde. So what we mean is this. Here is my interval 0, 1, and here I have this F. Okay. This function may start from any point. Okay. So what we know is this. F of 0 is just x0. It doesn't have to be a loop. Okay. It's not necessarily a loop. And here I have the real line. And here we have the map P. And then we have a point here, x0 tilde, which is mapped to x0 under the covering projection. Okay. What this fact tells us the following. If I have this picture, then there is a unique function f tilde, so that when you come back via the covering projection to the circle, you will get f's. In other words, f is just P composition f tilde. Okay. So this is a fact. We will prove this. And this fact will just give us the injectivity part of our, statement that this map is an isomorphism. So injectivity will follow from, not injectivity, I am sorry, surjectivity will follow from this. How is that? Let's see. Okay, let me. Okay, so note that this fact proves that our map is surjective. Now let's see how this is done. Okay. Now let F be any class. So it's a loop, right? It's a loop starting and ending at x0. In this case, x0 is this fixed point. Okay. Now, by the fact over there, so by the fact, let's say A, that fact, there is a lift. Lift means a function, continuous function from 0, 1 into R. Okay, here let me say, let x0 to be x0 tilde to be 0. Okay, note that the image of this x0 tilde is just x0 under the function covering projection P, right? Now, so if I, okay, so I am using this fact. I have x0 and x0 tilde, which is mapped to x0. And if I have any path starting x0, then there is a unique lift. Uniqueness actually is not needed here, but existence is needed. So there is a unique lift so that F0 tilde is just x0, which is 0, and F is just P composition F tilde. Okay. Well, because of this, we have the following. F0 tilde, sorry, not F0, but okay. P of F tilde 1 is just F of 1, and that is x0, right? Because the fact tells me that I have this, therefore, P of F tilde 1 is just F of 1, and it is this one. Therefore, and hence, this point is in the pre-image of x0. X0 in our case is, of course, just 0, not 0, sorry, 1, 0. And what is this? This is the set of integers inside R, right? The points which are mapped to 1, 0 is the set of integers. Okay. Hence, F tilde 1 is just n for some n in Z. Okay. Thus, F tilde is a path from 0, 1 to R from 0, 1 to R so that ya da şöyle diyeyim, starting at x0 equals 0, x0 tilde equals 0, and ending at hangi noktada? F tilde 1, which is n. Ama o zaman şunu söyleyebilirim. Then the homotopy class of Wn, sorry, homotopy class of F, F is just P composition F tilde, okay? But this is just a path, continuous path from 0 to n, and actually there is another path which does the same thing, right? Wn tilde, it is also a path from 0 to n, And we know that if there are two such paths, then their composition via P represents the same homotopy class. And the homotopy class of this is just, of course, Wn. So what we see is then this homotopy class is equal to this, and that is just the image of our homomorphism. Therefore, hence, this map is onto. Okay. Note that I started with some element in this group, and we showed that that's the image of some integer. Therefore, our map is onto. Tamam mı? Peki, şeye bakalım. For injectivity of our homomorphism, we will need another path, sorry, another fact, and it is the following. Let F be a homotopy. Part A gives us lifts of paths. Part B will give us lifts of homotopies. Okay, so basically they are the same result. One of them has domain and interval, it's a path. The other one has domain like this, and it's a homotopy. So let this be a homotopy. Homotopy from f of s, which is fs0, to g of s, which is fs1. I do not care about the endpoints yet. So this is a homotopy, so that at time 0 it is a map f, at time 1 it is another path, which is g. And let f tilde be a lift. Be a lift of f of s, which is this. Yani elimde bir homotopi olsun f'den g'ye ve homotopinin bir ucunun lifti olsun. So I have a homotopy from a function to another function, and one of the functions, the one which corresponds t equals 0, that function has a lift. So that's our assumption. Then the conclusion is the following. Then you can just lift the whole homotopy. Okay. Then there is a unique lift f tilde. So you can lift the homotopy, okay, of f. In other words, I have this. If you compose this homotopy, you get the homotopy down for all ST in I cross I. So what I mean by a homotopy, lift of a homotopy is this. Okay. First, note that these two statements are almost identical. Why is that? In the first statement, we had the following. I have a path, and one end of this is lifted. This point is mapped to x0, and I am given a point x0 tilde, which just lies above x0. So you can just see it this way. This is also a homotopy of maps from points. This point is lifted, then this homotopy has a unique lift. Okay, once you lift one end of the homotopy, the whole homotopy extends or lifts in a unique way. And here we have the same picture. So here I have F, okay, and it maps to circle, and then here I have real line. And what we know is this. Okay, sorry. If this, so here I have F and G. If this F has a lift here, okay, if I have a little f tilde, so this is the t axis. So if one end of the homotopy is lifted, then the whole homotopy is lifted in a unique way. So I have f here, and then this will extend whole square, and I will get f tilde. Peki. Şimdi iddiamız şu. This fact, so B, proves that our homomorphism is injective. How? Well, to see this, let image of an integer is equal to image of some other integer. This means what? Hence, thus the paths, the loops Wm and Wn are homotopic, right? Homotopic by some homotopy F. So that ne var? İşte homotopinin bir ucu Wn, diğer ucu Wm. Uç noktalarda x0'a map ediyor. So f of these are homotopic means S0 is WMS, S1 is WNS, F F0t and F1t are all x0 for all S and T. So we have something like this. I have a homotopy F. This and is mapped to x0. This and is mapped to x0. This is Wm and this is Wn. Okay. Zamanım var değil mi? Hala. Evet varmış. Okay, now we know that Wm tilde from the interval into R is the lift of Wm, right? In other words, this satisfies the following. P composition Wm is just Wm tilde is just Wm, right? We know this. But then this fact B tells us what? Fact B tells us what? Okay. If I have a homotopy between two functions, then this homotopy F has a unique lift F tilde. Okay. Lift means just, it's a function to R, so that its projection via P is just F itself. Okay. So now, by the fact B, there is a unique homotopy. There is a unique lift F tilde of F, so that F tilde is from where to where? So that F tilde S0 sıfır koyduğumda bu işte şu lifte eşit. Tabii ki lift olmasından dolayı şey de biliyoruz. F ST is P of F tilde ST. Okay. Or all ST in I cross I. Şimdi bu ne anlama gelecek, ona bakalım. Okay. Now, I have F here. This and is mapped to Wn. This and is the mapped to W. No, this is M, this is N. Tahtaya yazdım da elimdeki notlar biraz farklı. Şöyle. Şurası M. Bir de F tilde var. Unique lift. Ne biliyorum? Bildiğim tek şey şu. Bunun lifti, bu parçanın lifti tilde. Şuraların ne olduğunu bilmiyorum. Ama şunu biliyoruz. F st is just P of F tilde st for all S and T. Now, let's see. Of course, this point x0 is just the point on the circle, which is 0, 1. And I know that this end is mapped to 0, right? WMS is the function which sends 0 to 0, of course, because the formula for this, S is sent to M times S. So when S is 0, it is 0. And this end is sent to M. Okay? And then I can do the following. You see, 1, 0, which is just x0, and that is the image of this for all t, but I know that f is just p of f tilde s, 0t, for all t 0, 1. Therefore, this thing is always mapped to x0, right, for all t. Therefore, this f, this lies inside pre-image of x0. And what is the pre-image of x0? Well, this is the set of all integers, right? Integers are mapped to the point x0. But then we have the following. So this is true for all t in 0, 1. Well, so this means what? This end of this square box continuously mapped to the integers. But this is a connected interval, connected set. Its image should be connected, but it is sent to integers. Therefore, it should be a constant integer, right? Therefore, this thing is a constant function. But at this end, it already takes the value 0. Therefore, on the whole interval, it should take the value 0. Okay? So the conclusion is this, is the following. Since f tilde, the continuous function, f tilde maps 0, 1 to z, yani buradaki şeyimiz şu. Şunu biliyorum. Bu integer for all t. And 0, 1 is connected. F tilde should be constant on where? On işte 0 çarpı interval. So this end, okay? 0 times interval. But on one point, it takes already this value. So f 0 s, since this is constant, it should be equal to the value at this point. But I know that this end point is already mapped to Wm of 0, which is just 0. Therefore, we have this for all s. What about the other end? Well, the story on this end is the same. Instead of 0, I have another integer m, but the story is the same. Okay, so the same argument will show that my homotopy is also constant on this end, and that constant is nothing but m. The same story, okay? Instead of 0, I have just m. So similarly, f tilde 1s will be just m for all s in the interval 0, 1. Therefore, this end of the homotopy is mapped to m. All right, I guess my time is up. Yes, so let me give break. After the break, we will continue.